All right, so this is problem number 5, and it looks like you actually know how to do the process. It's just so that when the fractions are there, it kind of throws you off. So, one of the ways that you can look at this problem is that you can see it actually typically when we write it in algebra, you're going to see it like this: 1/5 times n equals 9. So, that's how you'll see it. But the way that you're going to look at it here, okay, is you already know it's broken apart. You've got your variable times your constant equals your number or your constant. It's also a constant. All right. So the purpose when you have a variable is you want to get it by itself. So the first thing you're going to ask yourself is my variable by itself? And remember, the variable can be any letter. It can be N, it can be Z, it can be Q, it could be I, whatever. Okay, so what I like to do is I like to draw this line right here to separate it out. Okay, that way my variable and my operation, add, subtract, multiply, or divide, and my constant are all going to be on the one side. And then you have your equal sign and you have your number. Okay. So you know that you have to, the opposite of multiplying by a fraction is going to be to do the opposite, right? So we know that we're going to have to do the reciprocal. Okay. So we have our fraction. So what we're really doing, and it looked like you try to do it, is we're going to multiply by 5 over 1 because we're doing the reciprocal. Okay, so the remember the opposite of multiplication is division. So we've got the reciprocal, and right here you crossed out your fives, which was great because 5 times 5 is equal. Let me write it down here. I'm going to pretend that I'm multiplying these. N equals 5, okay, times 1 and 5 times 1. Okay, so you know that that's going to cross out and it's going to give you that 1 that you want. All right, so those cancel out, giving me 1. But this right here is the fraction, the reciprocal that you're multiplying by. So what you do on one side, you're going to do to the other side. All right, so there's my process again. All right, so I'm going to multiply by 5 over 1. So when I multiply 5 over 1, okay, you can even put a 1 over here if that helps you out. And then when you multiply a fraction, you just multiply across, multiply across. All right, so it's going to give you n is equal to 45 over 1, which you don't need the 1, so n is equal to 45. All right, so that one is, I believe, number 5. All right, so when you look at, hang on, let me see if I can click out for a second. When you look at the next problem, okay, it's also going to have a fraction. And when you have the fraction, okay, just think about because you understand the process based on your work. I can see that you understand the process. So you have 2/3 times x is equal to 15. So what is the opposite? It's going to be the dividing by a number. All right, so 2/3 is going to be our fraction. So you're going to use the reciprocal because remember you want it to equal to 1. So the reciprocal of 2/3 is actually 3/2. Okay, because right here, 3 times 2 is 6, and 2 times 3 is 6. So 6 over 6 times x is equal to 15. Okay, and that's going to give you 1 whole, which is what you want. So what are you multiplying by? Got to go back up to that reciprocal right here. And we're going to multiply 15 times 3 over 2 because our starting number was that 2/3. So then, kind of cancel, move it over like this. X will be by itself. If you want to put a 1 right here, you can do that. And we multiply across. So 15 times 3 is equal to 45. And 2 times 1 is going to be equal to 2. Now that's an improper fraction, so we're going to divide 2 into 45. Two goes into 5 2 times. I'm going to run out of space. With the leftover of 1, so we've got to annex that 0, add the decimal, and the answer is 5. X is equal to 22.5, or 25 and 1/2. And that's how it's done.